Let's take a look at limits. So a limit is the value that a relation gets close to as x, or our variable, approaches, but never reaches. And our form to kind of show that we're talking about a limit is lim, and then beneath it, x approaches some value, and then our function, whatever it is. Eventually, we might put an actual formula here or something, but for now, we're going to be looking at graphs. So let's describe this. X would be our independent variable, and n, the number that it approaches. And sometimes we can find our limit as simply as putting n into the function to figure it out. But since we'll be looking at pictures, we won't be able to do that. So let's take a look. Let's start simple. Here's our function. We'll call it f of x. So this is f of x. And we want to find the limit of f of x as x approaches 3. So our variable is approaching 3. So 3 is right here on the x-axis, and we're approaching 3. So I'm basically finding the y value. So as x approaches 3, doesn't matter which way I come from, it looks like our function is getting close to 3. I'm basically reading the y value. You could think of this as the y value that we want. All right, let's take a look at this next one. So as x approaches -1, so -1 is right here on the x-axis, and we can see that we are approaching 4. And f of x, the limit of f of x as x approaches -6. Well, -6 is right here. So let's see, as x approaches -6, what does y approach? Well, y approaches 2. And how about the limit of f of x as x approaches 10? So 10 is right here. So if we take a look, we're approaching, doesn't matter which way we come from, we're approaching this value right here. So 2, 4, 6, 7. So these are, again, we're reading y values of this. What is the function value as x gets close to a certain number? So what about a situation like this? Now, I've drawn in blue some asymptotes. We have an asymptote that's horizontal, and an asymptote that is vertical, and we have our x and y axis, and in red is our function. Now we have the limit of f of x as x approaches 3, but notice right here we have a little symbol, a little minus. Now that doesn't mean -3, nor does it mean like a negative exponent. This simply means from the left, or negative side. So I'm going to approach 3 specifically from the left. So 3 is right here. And if I approach from the left, well, the left is over here. So if I approach 3 from the left, I see that my function gets really, really big. In fact, it's approaching infinity. So I would say positive infinity right here. So what about this one? The limit of f of x as x approaches 3, but now a plus, that would mean from the right. So now I'm going from a certain direction, or the positive side. So I'm going to approach it starting from the positive side. So the positive side is over here. So if I approach 3 from the positive side, now 3 is still right here on the x-axis. There's 3. If I approach 3, I see that my graph is going infinitely down. So infinitely negative, so negative infinity. So now I've asked this question right here. What is the limit of f of x if x approaches 3, and now I don't have a direction? Well, I got 2 different answers. From the left side, a positive infinity, and from the positive side, the right side, I got negative infinity. So what is it if I don't give a side? Well, if I got 2 different answers depending upon the side, I would say it does not exist. There is no limit. We can't find it because we get 2 different values depending upon which way we come from. So let's try this one. The limit as x approaches 9 from the positive side. So 9 is right here, and I want to come at it from the positive side, so that would be this way, and it looks like we're going to come to a 2, so 2. Well, what if I approach x from the 9 from the negative side? So that would be, we're still coming to here, okay, but from the negative side, so from the left, and I come to a 2 still, so 2. So now I've asked this question, what's the limit of f of x as x approaches 9? Now I haven't given a side. Well, this time I can certainly say 2. So if the side gives the same number, then we would say that the limit exists at that number. All right, how about the limit as x approaches infinity? Well, infinity is way off over here somewhere. And as I look at my graph is going far off to the right. What are we approaching, though? We're approaching this asymptote, aren't we? Now, remember, from the beginning, a limit is something that we're never actually going to reach, and we're never actually going to cross this asymptote. Well, where is that asymptote? 1, 2, 3, 4, 5. That limit is 5. What if we approach it from the approach negative infinity? Well, my graph is going close to, still, if I'm going to negative infinity, way off over here somewhere, we're getting close to this asymptote, but we'll never actually cross it. It's still 5. All right, a little bit more complicated setup, and now we have a jump right here. Let's see, the limit of f of x as x approaches negative 2 from the negative side. So negative 2 from the negative side. Now, negative 2 is right here. From the negative side, I would be coming up to here, and it looks like we are approaching 1, 2, 3, 4, 5. So 5. What if I approach negative 2 from the positive side? So that would be from over here, from the right. So if I approach it from the right, well, now it's not 5 anymore. It's 6, 7, 8, 9. It's 10 if I come at it from the right. Again, x is approaching a number, so I'm essentially asking, well, what's y approaching? The next one, what's the limit as x approaches negative 9 from the negative side? Well, negative 9 is right here. And if I approach it from the negative side, I see that my graph is getting very steep, but up positive infinity. What if I approach negative 9 from the positive side? Well, from the positive side, positive's way off to the right. If I approach it, I'm going very far down, so negative infinity. All right, so let's summarize those 4 questions. What's the limit then as we approach negative 2 without a side? Well, we got 2 different answers here for negative 2, depending upon which side we came from, so we'd say it does not exist. And for negative 9, again, we got 2 different answers depending upon which side we came from, so we'd say it does not exist. Last 2 questions for this picture. What's the limit of f of x as x approaches infinity? Well, infinity is way off to the right, and as I look at my graph, we're approaching that asymptote, and that asymptote is at 6, so that is approaching 6. It'll never actually get there, but it'll get close. If we go negative infinity, it's the same thing. We're getting close to 6, but that will not necessarily always be the case. All right, let's see if we can practice this. Let's see, f of x as x approaches infinity. So positive infinity is way over here to the right, and we are approaching this asymptote, so we're approaching 3. Now if we approach negative infinity, well, negative infinity is way off to the left, and if we approach that, well, now we're approaching this asymptote down here, which is negative 5. So negative 5. in that case. What's the limit as we approach -2 from the negative side? Now, -2 is right here, and if we approach it from the negative side, look where our graph's going. It's going infinitely down, so negative infinity. If we approach -2 from the positive side, look what happens. Our graph is going really big, so infinity. So what would we say right here? If we said, what's the limit as x approaches -2, but I don't give a side? We got two different answers, so we'd say does not exist. How about the limit as x approaches 6 from the positive side? Well, 6 is right here, and if we approach it from the positive side, that would be the right. Notice our graph is going infinitely up, so infinity. And if we approach 6 from the negative side, that's what that little minus comes from, then we're going infinitely down, so negative infinity. What would we say? What is the limit as x approaches 6? And I don't give a side. Well, it does not exist because we got two different answers depending upon if we came from the left or from the right. Okay, we're almost done with this. So let's take a look at this graph. This graph has a bunch of jumps, but these are going to work the same. Let's say I take the limit as x approaches 4 from the negative side. So that would be from the left. So I'm coming from the left, and if I look at my graph coming up to 4 from the negative side, this circle means if I were to do f of 4, there's an empty circle right there. The f of 4 is not that value. It's actually up here on this solid circle. So if I were to do the f of 4, I wouldn't get 4. I would get 7. But does that change my limit? Remember, I'm never actually going to get to 4. X is going to get close to 4. So as I get close to 4 from the left-hand side, I actually still am approaching 4. But what if I go to 4 from the right-hand side? Well, if I go to 4 from the right-hand side, well, now I'm approaching 7. Okay, that there's a hop here doesn't change how I do it. All right, so the limit as x approaches -6 from the positive side. So if I approach -6, -6 is right here. If I go from the positive side, that's from the right. So I'm going from the right. Looks like my graph is approaching -2. But if I go to -6 from the negative side, even though there's a hop right here, doesn't matter. We are approaching, looks like, -6. So what would we say about the limit? If I said the limit as x approaches -6 of f of x, what is that? Again, we got two different answers here. So since they're different, I'd say does not exist. But if they were the same answers, say these were both -2, well then it exists and it would be -2. What's the limit as x approaches infinity? Well, infinity, positive infinity is way off to the right, and I see my graph is going way high up, so infinity. All right, let's take another look at this and just briefly talk about continuity. A function or a relation is considered continuous if the limit as x approaches some number equals the value of that number. So if the limit actually equals the value for all the points on the interval, and usually we would subdivide various functions. We could look at the whole function, but if we had a function like this, I would have to say that this function is not continuous. But if I say just looked at this section right here, it's a nice smooth curve, no jumps or anything. That section is continuous. But if I were to include this section that I just circled, well then I would say it's not continuous or it's discontinuous. Why? Because I have a big gap right here. So you could kind of think of like continuity as being if our function is a smooth curve and we don't need to lift up our pencil to trace it. So if I came to here, I'm tracing, I'm good. Oh, but in order to continue tracing, I'd have to pick up my pencil and then continue. Therefore, this is discontinuous. But if I looked at, say, just this section, just that interval, well, on that interval, it is continuous. The long way to say that is if our limits exist and they approach the same number as the function's value actually is, well, then we are continuous.